All right, boys and girls. Parth, are you okay over there, Parth? Yeah? Let's talk about these two problems from yesterday, shall we?
Yes, sir.
It's a good idea, right?
Yes. Very good.
Very good idea. It's the best idea I've had all day. Tristan, you doing okay over there? Yeah, you having a good day? Okay. Are you ready for your quiz tomorrow? Huh? A lot of pressure. Got to do well. Well, let's see here. The first problem was 1 over what?
Y squared.
X, y squared?
Yeah.
Okay, and then plus or minus?
Plus.
Kevin, what was the next one? 1 over what?
1 over x squared y.
X squared y. And we have to add those, right?
Yes.
Is this a fraction? Is this a fraction? It's not a trick question. It's a fraction.
Yes.
And you're adding it with another fraction, right?
Yes.
And then you know that to add fractions you have to have a common denominator, of course, right? Okay. And you know the way you get common denominators is with multiplication, right?
Yes.
So Parth, like for example, if I needed to do 3/8 plus 1/5, you know that you have to find the lowest common multiple of 8 and 5, right?
Yes.
Are those two numbers relatively prime?
Yeah. Yes.
They only share a common factor of 1, so they're relatively prime. 8's not prime, but that's not what I was asking.
Oh, really?
Relatively prime means that they only share one factor of 1. So these are relatively prime. That means their lowest common multiple is their product. So you know you have to multiply this by 5 over 5 and this by 8 over 8, right? That's how it works, right? Same thing here. It's no different. We have to find the lowest common multiple of x y squared and x squared y. So let's take a look. X y squared, would that be x times y times y? And this would be x times y, right? Now look, after a little bit of time, this is way more natural than what I'm writing right here. Like you can just look and you realize that x and x squared, what do they both go into? What do they both go into? X squared. So how many times does this go into x squared?
Twice.
No, x times. Twice would be 2x. It's tricky, I know. All right, so let's take a look. Here's what they have in common. They both have an x, right? And they both have a y. Is that right?
Yes.
What's left over is another x and another y. So when you put all that together, this is your lowest common multiple. Good to go? Yeah? Allison, we're good with this or not good? So far, so good. Okay, so x squared, y squared. All right. What's missing from here to make this x squared, y squared? Of course, x, right? So then, Anaid, yeah? Hey, Reg, what does x divided by x equal?
1.
Oh, no, reg. Yeah, that's okay. But you're right, rag. It's 1. You guys agree? Something divided by itself is 1, unless, what would make this not equal to 1? Like x divided by x does not equal 1 if x equals this. 0. Can't divide by 0. Oh, dang, that's a good question right there. Huh. Parth, does that make your head hurt? Brandon's got to lose his head and his hood in class, doesn't he? Sorry, buddy. Sorry you're sick. So this one is x, yeah? And then plus this one, we have to multiply by y over y. Is that it? Are we done? Pierre, are we done? Is that it? Can it be reduced? Yeah? By what? By both. Whoa. Really? Let's see. So that would be like, if I reduced by x, if I reduce this, what? What? Can this be reduced?
Yeah.
Okay, by x?
Well, just the x divided by 1.
Okay, so I could reduce this x with this x squared, right? What would be left? What about on the top? So he says that would be 1 and that would be x. Okay. And what about the y's? So it would be plus, right? Plus what? Like, how would the y's reduce then? What do you think? So it'd just be 1 and y? So you think these two things are equal? I don't know. I'm asking you. It's one of the two. How could we know if these two are equal or not? How could we tell if this is the same as that? Any ideas, Diego? How could I tell if these two are the same? Multiply. What do you mean?
You have to get the same denominators when you multiply. To get the same denominator, you multiply.
Oh, I think here's what I think he's saying. You tell me if you got it, if this is right, and you guys listen, okay? So, Miss Beamer, here's what he said. He's like, look, to see if these two things are the same as each other, I could make this denominator back into that one, and then the numerator should also be equal, right? Is that what you're saying? So I should be able to multiply this by xy divided by xy, the whole thing, right? Okay. Well, I agree that it looks like the denominators work just fine. X squared, y squared. That's good, right? X times x, and yeah? Yeah? Okay. What about this? I'm gonna write this down here somewhere, okay? 1 plus 1 times x, y. Now, aren't we really multiplying the whole numerator times something? So wouldn't this be xy plus xy? And wouldn't that really equal 2xy? So these aren't the same. This and this are not the same. Whoa. Turns out this cannot be reduced. Reducing, oh my goodness, hold on. I hope you're taking notes, not just watching, because this is fancy right here. You're going to learn some stuff right now. Like, you're going to be so smart, your head is going to be like all, and you won't be able to get out of the door. X plus y over x squared, y squared. Let's take a look at the order of operations. You know, PEMDAS. Please excuse my dear Aunt Stinky. Or something like that. I forget. Brandon's got to lose his hoodie in class. He can't have that on in class. I'm sorry, Brandon. I know. Oh, but your hair looks lovely today, so don't worry about it. Brandon, when we're reducing, which one of these is happening? So I'm not saying that Brandon's right or not, but he said reducing is division. Do you guys agree or disagree? Crickets, 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 crickets. Some people are like, yeah, I got it. Miguel, what do you think?
I think that he's correct.
You think he's correct? Reducing is division. Yes, R-E-G. What's up, buddy?
Because you showed us that addition is not actually division, it's actually multiplication. So reducing is actually...
Division is multiplication of the reciprocal, you're right. So it's like, yeah, it goes right there. Because these two go hand in hand, you're right. Those two go right together. Okay. And then here's the other thing. I see addition here, don't you? And addition is like right there, right? And you're supposed to divide before you add, correct?
Yes.
But this is wrong. Why? Why is this wrong? You have to speak like way louder. Go ahead, tell us. I want to hear what you have to say. Why do we have to add these before we can divide? Well, all of these are different operations. I'm sorry? What?
Jeromson, instead of PEMDAS, one of my teachers last year taught me Jeromson.
Jedamson, what's that?
It's group,
Group. Oh.
then exponents.
Uh-huh.
Division and multiplication because it's in whichever is first.
Uh-huh. Left to right, yeah.
So division, multiplication.
Oh, is that different than PEMDAS?
Yes.
How?
Because we do grouping very
Hmm.
exponent behavior to say.
Well, here's the thing. Maybe you guys don't know this. That's actually the same. Because P stands for parentheses, but really what it is, it's anything that's grouped. Anything that's in a group. I agree. I don't like the letter P because then people just look for parentheses and I think that's it. And also people think PEMDAS is like its own math question. But order of operations is how we always do math. Always. This is a group right here. The fraction bar makes that a group. You have to do that operation before you can do division. We're not actually adding x and y down here, we're doing them in a group first. Since you don't know what x is and you don't know what y is, you can't add them together, so you just leave it like that. And since you don't know what they are, you can't reduce it either. Do you see, Pierre? Man. If you just learned something, you should probably write it down, because you're going to forget. That thing you just got your head around right now, you're going to forget it in like 3 seconds if you don't write it down. Tristan's like, did I learn something? Wait, is this second period? Are we in math? Cool. What's the matter, Diego? You don't have your head around it yet? Oh, man. Hey, Parth, you got your head around this? No? No? Who's got their head around this? Why you have to add these before you can reduce them? Tell us. Way in the back again. Go ahead. Yes, ma'am. Because they're grouped. How do you know they're grouped? I don't see parentheses there. The fraction bar makes them in a group. The fraction bar separates them. It separates the top from the bottom. It does. Other things do groups like square roots and all kinds of stuff. Brandon, do you have Ebola?
I don't know. I hope not.
Okay, me too, because then we're probably all dead. Yeah. Okay, check this out. I know we have one more homework question to do, but before we do, I want to show you something. You ready? That can be reduced. Holy moly guacamole. What's up, Dylan? Well, yeah, X, but that's in a group and I have to, how do I, what? Would you agree that's true? Would those two things be equal to each other? You guys never seen that, but have you ever seen something like happen like this before? Let's see. 3 plus 2 over 5. Have you ever seen that written like this? 3 over 5 plus 2 over 5? It's the same thing, right? That's what I did here, right? I just separated. They both have a common denominator, so, right? Abraham, no? Yeah? Talk to me, Goose. What's that? Maybe. Oh, that's good. That's perfect. That means you're about to learn. Huh. Wait, are you confused by this part right here? Or this part over here? This here? Well, do you see they both have, wait. Here's what I want to show you. These two are kind of like the same. I took this complicated, ugly thing and I made it simpler. And then I took that and I separated it, just like I took this and I separated it. Do you see how they're the same? Yeah? Okay. And this one, what's this equal? 1? Okay. And what's this equal? 1 over xy. Wow. That's weird. I know that's all new, right? But,
Not really the
yeah. Hey, Rag, will you tell me the other homework question we had?
It was, you have to reduce 15a to the power of 3 b squared over a to the 40 times a to the power of 5 b.
Just like that?
Yes.
Okay. Hey, Allison, I don't usually, like, what I'm going to write down, I don't usually write. And some of you guys, like Brandon, should probably be writing this down. I know you don't feel good, but, like, if you're just sitting and watching, you're probably not going to learn. But watch. You got this already. Did you get,
Yeah.
what'd you get?
Wait, what?
What'd you get then?
I got 120 to the 8. Oh wait, no, 120a to the 8th power and b to.
You didn't reduce, dude. You multiplied. Even if you got the right answer, does that mean you know?
No.
No. So watch. Check this out. Hold on. Watch. This is really like 15 over 40 times a cubed over a to the 5th times b squared over b. If you break it apart so that, you know, like the a's are in one fraction, the b's are in another, they're all multiplying, right? Miss Beamer, is that okay what I did right there? You sure? Do you see why I did that? Yeah. Now, I don't actually usually write it like that. I just, when I look at this, that's what I see. You doing okay with that, Jesus? You sure? Do you see why that's useful? What's this one going to be? Do you guys agree? 3/8? So this one is 3 over 8. Okay. Times, what about this one? Dang. Check this out. Tell me if you agree with this. So far, so good or not good? Yeah? 1, 2, 3, 4, 5. Good, not good? Hey, what's A divided by A? 1. Okay. So that's 1. Yeah? And this makes 1, right? And this makes 1. I don't need to write 1 times 1 times 1 over A times A, do I? Can I just write 1 over A squared? Oh, then how do you know I was writing? I'm being silly. It's a joke. Sorry, thank you. But do I need to write that, or can I just write that? They're the same, right? So this one is going to be Juan over A squared. I mean, here's what I see. I don't do this either. This is why it works, but here's what I see. I see 3 A's on the top multiplying together, 5 on the bottom. And so there's 2 more on the bottom. Do you see? 2 more in the denominator. So after you're done reducing, there's going to be 2 left over in the denominator. Okay, last one. Listo? Hey, b times what is b squared? B. This is just b over 1. So if I put that together, I get 3b 8a squared. This equals that.
I did it a different way. How do you get 1 divide b squared divided by b?
Oh, that's a good question. Yeah, you guys listen, please. A good question. The question is, where's that come from? Right? Well, check this out. B times b is b squared, right?
Yes.
Divided by b times 1, would that be okay?
Yeah.
B times 1 is b, right? Well, this reduces to make 1, so it's 1 times b over 1.
Okay.
Yeah? Cool. All right. Parth, how you doing with all that?
Very good.
Very